So a question has come up on how do you find the standard deviation when you are asked to calculate the z-score or the standardized statistic. So we're going to use the Buzz and Doris example that we've been looking at. And if you remember that in the Buzz and Doris example that Buzz pressed the correct button 15 out of 16 times. And our null hypothesis in that particular example was that the probability of successes was 0.5, right? That if just by random chance, the probability of him picking the right button would be 0.5. Now, how do we apply that for our standardized statistic? So the standardized statistic Z is made up of this formula that says we're going to use the observed statistic, which is here in the top of my fraction in the numerator, the observed statistic, subtract from that the mean of my null distribution, right, the average, the mean of our null that we're looking at, and divide it by the standard deviation of the null. So how do I find the standard deviation using simulation? So I'm going to come over here to our one proportion applet, and our probability of heads, or the probability of successes that we are looking at in the Buzz and Doris example, was 0.5. So that doesn't change. The number of tosses has to do with the number of the sample size, right? The number of repetitions that they did in this experiment, and they repeated the experiment 16 times. Or the number of tosses, excuse me, the number of tosses was 16. And now we are going to simulate this process for 1,000 different trials. Now remember, this number 1,000 is the same number that we have kind of concluded, I hope, up to now, as we have to repeat the simulation a large enough number of times for us to start to see what's going to happen. And we've kind of decided that 1,000 is the number we're going to use. Now, a couple of things I need to make sure is checked or unchecked in this applet. I don't want to animate it. I'm going to scroll over here and I'm going to hide the coins because I don't want to see that anymore. And then I'm changing the number of heads to now be a proportion. Most often we are going to be looking at the proportion of things happening and not the actual number of events occurring. So I want this to change to proportion, and you'll notice that the scale on the axis here turned into decimal values and therefore proportional values as well. So I am interested in finding the standard deviation, right, for this formula, and I'm going to find that by checking this summary stats option here. Now let's draw the samples of 1,000 different repetitions, and you'll see the standard dot plot that we've been getting over here, right, with our null distribution being in the center. The mean of our null distribution would be in the center. But notice that of these summary statistics here, right, of these repetitions that we simulated, the mean for what we simulated here is roughly close to the mean of our null, which is 0.506. But we also see a standard deviation, and this is the number that we're actually interested in. So we haven't really talked about, and we're not really talking about it until probably later on in the course, but the number that we're going to be interested in, the standard deviation that we're going to be using in our formula, is actually going to come from this simulated standard deviation here. And what we eventually kind of find out is that when I simulate a bunch of repetitions, the mean of my simulation actually is almost dead on to the mean of my population, or the mean of my null that I'm looking at, which is why we don't really have to worry about the mean that's showing up here in the statistics for our formula that we're going to use. Instead, what I want to see is the standard deviation, which we do. Now, how do I use this information combined with the formula over here on the right side of our screen to calculate the standardized statistic for Buzz? So let's clear this out for just a second. I just pulled up my calculator, and I'm going to go through and I'm going to take the numerator values first. Now, in our Buzz example, we know that the observed statistic, p hat, the proportion of times that Buzz picked the correct buzzer, was 15 out of 16 times, right? So p hat, the observed statistic for the Buzz and Doris experiment, was 0.9375. That is the statistic that is being referred to here in our formula for the z-score. That's the first value in the numerator. From that, we are going to subtract the mean of the null distribution, which is our 0.5 that we have over here. So I'm going back to my calculator. I'm going to subtract 0.5, and I find that the value in the numerator is this number here. I'm not done yet, though, because now I'm going to divide by the standard deviation of the null, which is this value that we found from our simulation. So I'm going to divide by 0.130. So I found out that the standardized statistic that I'm looking at here is about 3.4, so somewhere around there. That's the standardized statistic that I'm looking for. Now, what does that mean for us? Well, let me pull another screen over here so that we can see this. Now, in your reading or in the videos that you saw that when we calculate the standardized statistic, it is a means for us to be able to evaluate strength of evidence. And the standardized statistic shows up here on our normal distribution. And remember that the example I gave in class was talking about our SAT and our ACT scores and how we just kind of, in order to compare them, we kind of zero out the middle and instead start talking about, well, how far away is the data for either SAT or ACT scores from the middle? And this is what those standardized statistics look like. I'm going to start calling them z-scores or z-values. So the middle of our distribution is at 0. And as I move farther away, either above the middle or below the middle, you can see that these numbers are changing like they would on a normal number line. And as I get farther away from the middle, then these values here are standing for the number of standard deviations away from the middle that I am. We calculated Buzz's standardized statistic to be 3.4, and we can see that for a value of 3.4 standard deviations above the mean, then his results are not very likely, right? Because the majority of my results ought to be, if the standard deviation is small, the majority of my data would be in the middle. And the further I get away from the middle, the less likely I am to have values that are similar to the middle. So a z-score or a standardized statistic that falls this far away from the center, and you can see the chart up here, is very strong evidence against the null, right? Very strong evidence that that Buzz was not guessing and that he was in fact doing something else. And we found that out to be the same conclusion when we calculated using the p-value. So this is how we can find the standardized statistic as well as use it to evaluate strength of evidence.